Hello there. We are going to talk about something called radians. Radians versus degrees today. So if you look at the top here, we have radians versus degrees written here. And of course, we're talking about angle measures, not temperature. Radians versus degrees. Definition. It's a pretty important one here. If you understand this, this will make a lot of trigonometry easier for you. You have to memorize less formulas, as you'll just be able to kind of logically make your way through them. So by definition, 1 radian occurs when the arc length of a circle is equal to the radius of a circle. I'll say that again. 1 radian occurs when the arc length of a circle is equal to the radius of the circle. So the arc length of a circle is part of the circumference of the circle, right? It's a portion of the circumference. So here is my radius r in our circle, right? So that's r. So if I go I'm going to start right here because that's typically where we start on the positive x-axis, correct? And I rotate this axis. I want to rotate it up that direction, in the positive direction. When that rotation, going around the circle, the arc formed is equal to 1 radius. This angle right here, theta equals 1 radian. Alright, so if you kind of think about this distance right here and that distance right there, they appear to be similar, at least if I can draw it to scale at all. Okay, so that is 1 radius around the circle, which formed an angle of 1 radian. Alright, so now I'm going to go here and I'm going to try to make the exact same rotation. We'll kind of guesstimate here. It's going to end right here, so I'll color code that blue. Okay, that is another. So this is an r value right here, right? This is r. That's the radius. This is also r right here. But now our new rotation, right? Our terminal side. We start at our initial side. We rotate to our terminal side. I'll call that angle alpha. That whole thing starting here and rotating around. Alpha is equal to 2 radians. And let's go with we'll pick a dark color here and another R, right about there maybe. So if I go another radius around the circumference of the circle, I've now formed a new arc. Let's loop all the way around. Boom, right there. And the black one we'll call beta. And beta would be equal to 3 radians. Okay, now it really doesn't matter what size this circle is. If that's a radius of 2, these are all 2's, 2's, 2's. A radius of 10, they're all 10's. It doesn't matter. What we're saying is that the radius and the portion I'm going around the arc are equal to each other. That is when one angle measure of 1 radian occurs. Okay, so let's go around the circle. And let's see exactly how many radians are in a circle. And I'm going to do this just because it's a little easier for me to draw and to keep it symmetrical. I'm going to start going in the negative direction. Alright, so now I'm going to go down this way. That's the distance of r. Let's choose another color here. What do we have? We have a little teal going. Now I'm going to kind of do a mirror image here, just so I'm at least staying symmetrical. Hopefully my arcs are somewhat accurate. And looks like we got a little bit more to go. And this one's just right about there. There's another R. And we have this little area right there. Let's I'll just highlight that one. I'm running out of colors to choose, so we'll just do a different highlight it there. There we go. Now clearly that's not an R length, is it? So what do we have here? I forgot to write the black one here. That's the distance of R. We have 1, 2, 3, 4, 5, 6 point. It looks like each one of these are about 0.14. So we have 6.28 radians, approximately 6.28 radians. Now let's see, what do I have on half of a circle? 1, 2, 3.14 radians equals 1/2 of a circle. Now that should look familiar right there. 3.14 is pi. So pi radians, an angle of pi radians, right? An angle is defined by rotation. So if I rotate pi radians, that means I've completed half a circle. If I rotate 2 pi radians, I've completed an entire circle, or a period, or a cycle, or one full revolution. Okay, so 3.14 pi, 2 pi. Okay, they're all 6.28, all the same guys there. All right, 6.28 and 2 pi, 3.14 and pi. Okay, so this is the definition of a radian. So now let's compare them to degrees. All right, we've said that 1 radian is when the arc length equals 1 radian is when the arc length equals the radius. And then we said pi, pi radians is half a circle. Well, we know, because we've grown up dealing with degrees the whole time, that 180 degrees is half of a circle. So by the transitive property, we can say that pi radians is equal to 180 degrees. So how many radians is 30 degrees? Well, 30 degrees is 180 divided by 6, and 180 is the same as pi. 180 degrees, 180 is the same as pi radians. So 30 degrees is the same as pi over 6 radians. 90 degrees, well, that would be 180 over 2 radians, right? Pi over 2. 60 degrees, well, that's 180 degrees, or pi radians, divided by 3. So now we have a nice little conversion for radians versus degrees. And if you're one of those people that needs a formula, if you want to go from radians to degrees, you simply take your radians and you do what's called factor label, right? This is radians. I need to multiply by a form of 1. Well, a form of 1, just like 3 feet divided by 1 yard is a form of 1, 180 degrees divided by pi radians is also a form of 1. Radians cross out, pi's cross out. You get 180 over 6 is 30 degrees. What if you want to translate 2 pi over 3 radians into degrees? Well, same deal. 180 degrees over pi radians. Pi radians is gone. 180 over 3 is 60, so we have 120 degrees. Okay, and what if you want to go the other direction? Degrees versus radians. Same exact idea. So let's change colors up here a little bit. Let's say you have 135 degrees. Well, fancy form of 1. Pi radians divided by 180. And this is a little more difficult because you have to reduce 135 and 180, the degrees there. Degrees cross out, right? So I'm left with the unit of radians, and 135 over 180, certainly a 5 goes into them, right? So that gives me 27 over 36 times pi. And now we're down to some more comfortable numbers. They did both divide by 9, so we're at 3 pi over 4 radians. 3/4 of pi. Let's go back to our circle. We're saying that 3/4 of pi is equal to 135 degrees. Well, if pi is right here, right? 1/2 revolution is pi. 135 degrees is here. Does that look like 3/4 of pi? It certainly does. Let's take it in the highlighter. I mean, that's pretty easy to see. That's 135 degrees, that rotation right here. And I'm saying it's easy to see because we all know that this right here forms 90 degrees, right? 90-degree rotation occurred right there. And this is half of a 90-degree rotation, or 45 degrees, for a grand total of 135 degrees. And it's also pretty easy to see that that's 3/4 of pi, right? Because that's half a pi and that's half of a half, also known as a quarter. So 3/4 of pi radians is equal to 135 degrees. So that is radians versus degrees, and I hope you enjoyed learning about a new unit of measure. Have a good day.